July, 3 p.m. In the central Sahara, the air hits 47 degrees Celsius. You can feel the heat on your teeth. On that same afternoon, the global average temperature is 15 degrees, cool enough for snow in places. In 1 billion years, that second number will be the first number. The whole planet will be Sahara hot every day. Scientists call the moment when the oceans start to boil something you do not yet understand. Stay with it. Right now, the sun beams about 341 watts onto every square meter at the top of the atmosphere. That's today's number. Add 10% to the sun and Earth can't cool itself anymore. The difference sounds small. A kitchen toaster is small. It still burns bread. That extra sunlight is why the future is already written. And the ground under your feet is moving. Africa pushes north at 2 centimeters a year, about as fast as your fingernails grow. In 50 million years, the Mediterranean vanishes. Africa will weld to Europe, a single wall of mountains where sea used to be. Two facts that should not both be true. The planet looks permanent. The planet is already leaving. Go back 4.5 billion years. The sun was 30% fainter. Earth still had oceans. That faint young sun paradox puzzled geologists for decades. Life held on anyway. The sun has gotten brighter every 100 million years. Today it is 25% brighter than at birth. It adds about 1% each 100 million years. Now picture the system that keeps Earth cool. Rocks weather. Rain pulls carbon dioxide out of the air. Carbon gets buried in the sea floor. That is the thermostat. When it gets hotter, weathering speeds up. More CO2 gets removed. Earth cools. It has worked for billions of years. It will not work forever. The thermostat has a limit. When CO2 gets too low, plants starve before the cooling can help. Take another clock, the moon. Laser mirrors left by Apollo show it. The moon slides away at 3.8 centimeters per year. Fingernail speed again. Tides break Earth as it goes. Days get longer by 1 second every 40,000 years. 400 million years ago, a year had 400 days. Each day was 22 hours. The planet you stand on today is not the one you were born on. Nothing has stopped moving. If you ask what kills Earth, most people answer humans. They picture carbon, warming, plastic, nuclear war. That story feels right for the next 10,000 years. But geology erases that story fast. The Anthropocene was voted down in March 2024. Geologists said human traces will be a thin line in rock, not an epoch. Forests will return. Carbon will wash out. Take the last 10,000 years. Sea level rose 120 meters after the Ice Age. Niagara Falls has cut back 7 miles in 12,000 years, at less than 0.3 meters a year today, with dams. Without people, it would cut faster. In 50,000 years, Niagara will be gone. It will have chewed back to Lake Erie. The Great Lakes will be a river. The Himalayas rise at 5 millimeters a year. In 1 million years, they will be hundreds of meters taller, then worn down. The Sahara greens and dries every 20,000 years with Earth's wobble. All of this suggests a comforting idea. The Earth breathes in and out. It recovers. It stays like this. That is the wrong answer. It feels good for a minute. You are thinking, come on, the sun is stable. It rises, it sets. The continents drift, but they always have. Life survived ice ages and meteors. So why would it stop now? Picture this one case. Take a house with a thermostat. You open a window in winter. The heater works harder. Temperature holds. That is Earth for 4 billion years. Volcanoes puff CO2. Weathering pulls it down. Balance holds. So you think the thermostat will hold forever. Put the two numbers side by side. Sunlight up 10% in 1 billion years. Thermostat down because CO2 is already at 420 parts per million today. There is not much left to pull. At some point, the heater wins. That point is not an opinion. The man who built the modern habitable zone, James Kasting at Penn State, ran the numbers in 1993. His model showed Earth's oceans vaporizing at 0.84 astronomical units of sunlight, refined later to show Earth leaves the habitable zone in 1 to 2 billion years. A year later, Ken Caldera with Kasting revisited it and found a C4 plant biosphere could survive another 0.9 to 1.5 billion years after today. depending whether heat or CO2 kills first. The water does not boil at once. First, the sky gets wet. Here is the mechanism. The sun fuses hydrogen into helium. Helium is denser. The core shrinks and gets hotter. Hotter means brighter. Every billion years, the sun is about 10% brighter. That is 10 toasters where there were 9. Earth warms a little. Warm rock weathers faster. Rain hits more exposed silicate. Chemical reactions lock CO2 into limestone on the sea floor. CO2 falls. That sounds like cooling. It is, but you cannot cool below the CO2 floor that plants need. Go back to today. Put your hand on a leaf. C3 plants, wheat, rice, trees, fail below about 50 parts per million. C4 plants, corn, sugarcane, hang on to about 10 parts per million. Cam plants, cactus, a little lower. At 600 million years from now, models put CO2 near 50 parts. C3 plants die first. Forests thin. At 800 million to 1 billion years, it hits 10 parts. Even the toughest grasses die. The land turns brown before the ocean boils. Animals that eat plants go with them. At Potsdam, Siegfried Frank and Christine Bunama pushed that lifespan in a coupled carbon model to about 1.6 billion years, with only 27% of the land still able to support photosynthesis after 1 billion. This is not guesswork. The carbonate-silicate cycle is chemistry. You can watch it in rivers today. More heat, more ions in the water. More rock turned to mud. The sun turns the knob. The rocks answer. The air empties. Now add the continents. They do not wait for the sun. Africa moves north at 2 centimeters a year. Add it up. In 10 million years, it is 200 kilometers closer. In 50 million years, the Mediterranean closes. Africa and Iberia collide with Europe. The sea that was there becomes mountains. Go to that year. Picture the map. The Atlantic is a little wider. Australia has crept north towards Southeast Asia. California has slid north to Alaska on the San Andreas. The man who drew that map first, Christopher Scotese at the University of Texas at Arlington, named it Pangaea Ultima in November 1982. He later called it Pangaea Proxima, the next Pangaea. Whatever the name, the shape is the same. In 250 million years, the Atlantic shrinks shut. A merged Africa and Eurasia crashes into the Americas. Australia and Antarctica join. One supercontinent circles the equator. Models run by the group that included Alexander Farnsworth at the University of Bristol put numbers on what that does. In Nature Geoscience in September 2023, they found much of Pangaea Ultima baked above 40 degrees Celsius for months at a time. Up to 92% of its land became uninhabitable to mammals. Volcanoes along the new sutures pump more CO2 at first, then weathering pulls it again. Summers are furnace, interiors are dust. This is not theory alone. The last supercontinent, Pangaea, broke apart 200 million years ago. When it was whole, its interior was desert. Coal formed on its wet edges. We have done this before. The planet has. Take the sun again. 1 billion years from now, it is 10% brighter than today. That sounds polite. 10% is a small tip. On a planet, it is not small. Mean sunlight at the top of the atmosphere will be about 375 watts per square meter. Today, it is 341. Surface temperature by then averages near 70 degrees Celsius if you count humidity, or about 47 degrees even with some reflective clouds. Both numbers are above a human body. Both are above most animals. Water starts to act differently. Warm air holds more vapor. Vapor is a greenhouse gas. More vapor traps more heat. More heat lifts more vapor. That loop is the moist greenhouse. Stratosphere gets wet. Water climbs high enough that ultraviolet breaks it apart. Hydrogen escapes to space. The oceans leave not by boiling over a stove, but by leaking away a molecule at a time. A study in 2013 pushed that tipping point to about 1 billion years from aerosol and cloud models. Earlier work said a few hundred million sooner. Either way, the order stays. And a 2021 model by Kazumi Ozaki at Toho and Chris Reinhardt at Georgia Tech ran it with mantle interaction and got 1.08 billion years, plus or minus 0.14, for oxygen to stay above 1% of today, then crash by 1 million times in just 10,000 years, before the oceans fully leak. First the land dries, then the air thins, then the sea goes. In 600 million years, complex land plants are mostly gone from low CO2. In 1 billion years, the sea surface is near 70 degrees. Fish are gone long before that. In 1.2 to 1.5 billion years, even microbes that need water struggle. If you want a line to picture, think of a kettle left on low. It does not whistle at first. It just gets lighter. You might say this is all model. You would be right to say that. Models are wrong in detail. They differ by hundreds of millions of years. Some put the 50 parts line at 400 million years, some at 650 million. Some add 2 billion years of thin plant survival if C4 takes over and temperature tolerance widens. That is real uncertainty. And the skeptic is right about something else. Earth will not go quietly from one number. Life bends. Cyanobacteria survive snowball Earth twice. Lichens live on dry rock today at -40. Deep microbes live kilometers down where water stays liquid longer. Plate tectonics may pause when water leaves. Without water, rock gets stiff. Volcanoes slow. That slows weathering. That leaves a little more CO2. So the end is not a sharp wall. It is a slope. But a slope still ends. Put the two objections together and the answer does not save you. Whether C3 dies at 600 million or 900 million, it still dies while the sun is still on the main sequence, still fusing hydrogen, still not a red giant. Whether the moist greenhouse starts at 700 million or 1 billion, the ocean still leaks away in the next 2 billion. The long habitability run of 6.3 to 7.8 billion years total that Rushby and colleagues calculated in 2013 counts from formation. We are already 4.5 billion into it, half done or more, and we have not yet talked about the next act. Slow down. Go to 600 million years from now. Stand somewhere that is now Kansas. It is not Kansas anymore. It is interior Pangaea Ultima, near the equator. Noon. The air is 42 degrees. Not a record. Just noon. The sky is pale because there is less blue scatter from thinner air. Trees are gone. What you see is scrub that looks like wire. Waxy C4 grass, a few cam succulents that close by day. No bird song. Insects, maybe. Beetles that hide under stone until dusk. A dry riverbed cracks in polygons the size of tables. You kneel and touch it. The dust is soft as flour. That dust used to be soil. In a microscope it was full of fungi and roots. Now it is ground rock. The sun looks the same to your eye. It is not. It is 6% brighter. You would not notice the extra wattage. Your skin does. You would sunburn faster. You can picture water off to the east, but it is 800 kilometers away. Monsoons still hit the coast. They dump rain on mountains that were the old Atlantic suture. Inland, almost nothing comes through. At night it drops to 12 degrees. The desert breathes. Something rustles. A small mammal if mammals made it through the heat. Or a reptile that does not need much food. This scene is not punishment. It is physics. Light plus rock plus air. Rewind out. The story does not end with a hot desert. In about 5 billion years, the sun runs low on hydrogen in its core. The core contracts. The outer layers swell. The sun becomes a red giant. How big? More than 100 times wider than now. About 256 times the sun's present radius. Around 1.2 astronomical units. That is past the orbit of Earth today. It will be about 3,000 times brighter than now at peak. Mercury and Venus will be engulfed. They will not outrun it. As the sun loses mass, about half its present mass by then, gravity loosens. Planets that survive drift outward. Earth should drift from 1.0 to about 1.5 astronomical units as the sun sheds mass. But Robert Schroeder and Robert Smith showed in 2008 that tides and drag pull it back. Any world starting below 1.15 astronomical units is still swallowed. Earth starts at 1. Swallowed or not, Earth is scorched. Surface rock melts. Any remaining atmosphere is stripped. The sun loses about 4.9 times 10 to the 20th tons per year near the tip, 8% of Earth's mass each year, shedding shells. The sun at 7.6 billion years will reach its maximum red giant size, extending 20% beyond Earth's present orbit before it collapses. After that it shrinks. It throws off its outer shells. What is left is a white dwarf, size of Earth, mass of half a sun. A teaspoon of its material weighs about 5 tons. It glows white hot at first, then cools for trillions of years to a black dwarf. Around the same window another clock ticks. Andromeda, About 4.5 billion years from now, the Milky Way may hit Andromeda. The Triangulum Galaxy may join. Hubble and Gaia data re-examined in 2024 put the chance near 50% in the next 10 billion years. Not certain anymore. If they merge, stars rarely hit each other. Space is mostly empty, but orbits are churned. The Sun, Earth if it still exists, could be flung to a new edge of the merged galaxy they call Milkomeda. Night sky would be fire. Now go even farther. Picture Earth if it survived the red giant and the galaxy merger, orbiting the white dwarf. The Sun is now smaller than Earth, half its old mass. Its light is dim. Earth would be frozen. Maybe 8 billion years from now, an example exists 4,000 light-years away. A rocky planet about Earth size found around a white dwarf, spotted with Keck in 2024, sits beyond what would have been Mars. That is the template. Over trillions of years, that white dwarf cools. It will no longer give enough visible light. Photosynthesis ends for good even if air returned. Tides still work. If the moon is still there, it will be farther. Earth rotating slower, days equal to months. Gravitational waves will bleed energy from the orbit. Slowly, over a trillion years, Earth will spiral into the black dwarf that the Sun became. That timescale dwarfs everything else. The oceans lasted 1 billion. The continents lasted a few hundred million. The Sun lasted 10 billion. The cinder cools for quadrillions. You wanted a single date for the end. There is now one. There is a sequence of ends, first for forests, then for seas, then for rock, then for light. Take a kettle, a continent, a star, a galaxy. Each has its own timer. None waits for us. Add one more clock. Earth's core is cooling. The magnetic field that shields us comes from molten iron spinning. That dynamo will fade. Estimates vary, but in 2 to 3 billion years, the inner core grows large enough and convection stalls. Without a field, solar wind strips air faster. Mars lost its water that way. Earth kept its field longer because it is bigger and wetter, but not forever. When the oceans are gone, plate tectonics stops. You need water to make rock slippery. Without water, plates lock. Volcanoes choke. Mountains stop rising. Erosion still works, but there is less to erode. The planet becomes a desert of still plates, like Mars now. Then the red giant bakes it flat. Picture a beach pebble. The waves have been rounding it for millions of years. Then someone puts it in a furnace. That is the difference between tectonics and the Sun. One sculpts, one erases. People ask if technology saves us. Could we move Earth? Ideas exist. Build a shade. Tow the planet with asteroids. Engineer algae to pump CO2 back. All take energy we do not have, over times we do not control. The last time CO2 fell this low, plants learned new tricks. C4 photosynthesis evolved about 30 million years ago when CO2 dropped to near 300 parts. It squeezes more from less. That buys time, not eternity. 10 parts is near vacuum for a leaf. No trick beats that. So the sequence holds even if you argue the numbers. The first loss is green. The last loss is blue. Where do we fit in this? For scale, take the Holocene, the 11,700 years since the last ice age. Everything you call civilization sits in that sliver. Cities, writing, steel, satellites. In rock terms, that sliver is a line thinner than paper. Future geologists, 1 million years from now, might find a dark seam. Carbon bump, nitrogen from fertilizer. A spike of plutonium from tests. Bones of chickens, which outweigh wild birds today by 3 to 1. Then nothing. Human mass today is 30% of land mammals, farm animals 67%, wild mammals 3%. That ratio will not fossilize well. Erosion will chew most traces in a few million years. Subduction will drag some down. What lasts? A monazite grain. A few isotopic shifts. That is the material answer to the humans kill Earth story. We change the air for a blink. The Sun changes it for 1 billion times longer. Put the two side by side. One cigarette in a room, or the heater left on all winter. Both warm the room. Only one stays on. The other wrinkle is time for evolution. After Pangaea Ultima breaks up, if it does, new oceans open, new coasts form. Life that survived the heat could radiate again. After the oceans go, life retreats to seeps, to deep rock, to brines that linger in shadow. That retreat could last longer than dinosaurs lasted. We talk about Earth as dead at 1 billion years. Microbes would disagree. They lived without oxygen for 1 billion at the start. They could live without oceans at the end, in pockets. But a planet with only pockets is not Earth as you know it. Peter Ward and Donald Brownlee made this point in Rare Earth in 2000 and The Life and Death of Planet Earth in 2003. Complex life is not just rare in space but rare in time. We live in the middle window when both air and water allow it. So here is the time-lapse, compressed to one breath. Africa hits Europe, Mediterranean gone, Alps higher, Atlantic closes, Pangaea Ultima forms, interior 40 degrees and dust. CO2 slides below 50 parts, wheat dies, then grasses. Sunday 10% brighter, oceans at 70 degrees, sky wet, hydrogen leaking, land brown, sea leaking. 2 billion years hot, 5 billion sun swells, 100 times wider, 3,000 times brighter. Mercury Venus gone, Earth scorched or swallowed. 7.6 billion sun at biggest, then white dwarf, Earth frozen, size of a marble next to its cinder. 4.5 billion Andromeda brushes or misses. Milkometa if it hits. Trillions white dwarf cools to black. A trillion Earth spirals in. That is the whole arc from beach pebble to cinder. Now the question that does not close. If a world ends in steps, when do you say it died? When forests died, when seas dried, when rock melted, or when light went out? Most clocks we used were discovered after you were born. Pangaea Ultima named 1982, Moist Greenhouse modeled 1993 and refined 2013. Andromeda odds cut to 50-50 in 2024. White dwarf planet found 2024. Oxygen crash at 1.08 billion years dated 2021. We are still learning which step is first, and the sun has not yet added that first 1% in our lifetime. You can test the mechanism today. Take a weathered hillside, measure the water, count the ions. Watch rock become air become rock. The ticking is quiet. You have to listen. The planet looks permanent because you are short. It is not. If you step outside tomorrow, look at the sun for 1 second and then look away. That after image is 10% of the extra light that will end the oceans. Hold that glow in your eye and remember it. It was here before you arrived, always. One more detail to carry. The faint young sun should have frozen Earth at the start. It did not because CO2 was high then, thousands of parts. Volcanoes made more. Life had not yet pulled it down. That is the same thermostat running backward. High CO2 compensated for low sun. Now the thermostat runs forward. Low CO2 cannot compensate for high sun. The system that saved the child kills the adult. You can see that reversal in rocks. Banded iron, tillites, coal, each is a node. And the man who first put the numbers together for the future was not trying to scare anyone. He was mapping where water stays liquid. That map now says Earth has between 1 and 2 billion years of liquid surface left while sun stays normal. After that, water stays but is steam, then no water. The difference between those two tells you which futures to care about. The next 10,000 years are ours to lose. The next billion are physics to watch. We used to think galaxies colliding was certain. New numbers made it half. We used to think red giant would swallow Earth for sure. New mass loss models make it maybe. The only thing not moved by new numbers is the slow brightening. That was measured by watching other stars like the sun. It is not a model tweak, it is fuel. Fuel runs out, light goes up, rocks weather, air thins. That loop has no vote, it just runs. You can love the planet and still watch it leave. That is the time lapse. Take this one case. Hold a leaf, a stone, and the sun in your mind at once. That is Earth.